Hi, I'm Vasav, and welcome back to CoolCube. So today on CoolCube, we're going to be talking about current, resistance, and Ohm's law. Compared to voltage, I think that current and resistance are a bit easier to understand, so let's get right into it. Okay, so first off, what is the dictionary definition of current? Well, current is the rate of flow of electric charge past a point or region in a circuit, pretty much. So let me write that out. Okay, so what exactly does that mean? If you think of voltage as sort of the pressure, right, in a circuit, if you're gonna make an analogy to like a water tank, if you think voltage is the pressure, current is the flow of the water, right? So current is measured in amps, which is just A is the symbol for amps. And it's basically just the flow of charged particles. As you can see in this image on the left, current right here is trying to get through this narrow tunnel. Voltage is pushing it, and resistance, which we're about to talk about, is sort of keeping it in place and trying to stop it from moving. Speaking of resistance, let's talk about that. What exactly is resistance? Well, the dictionary definition of resistance is the measure of opposition to current's flow in an electrical circuit. So let me write that out. Okay, start again now. And it's measured in ohms. And ohms have this really cool symbol, so I'll show you it. Let me write it out. This is the symbol for ohms. And if we're going back to that example where we're in a water tank, right? Voltage would be the pressure, current would be the flow of the water, and resistance would be anything trying to stop the water from coming out of the tank. That's pretty much it. So now you might be thinking, okay, I know voltage, I know resistance, I know current, but what's the use? I'm about to explain to you something that takes use of all three of those things and is actually really useful in determining different values in a circuit, and that's called Ohm's law. So you might be wondering what this pyramid stands for. Well, Ohm's law in essence is literally just a formula. What it says is voltage equals resistance times current, or voltage equals current times resistance. So I'm going to write that out. V stands for voltage equals I, which stands for current, times resistance, R. And that's pretty much what this pyramid stands for. It's a really nice way to memorize it because, for example, let's say you want to solve for voltage, right? All you have to do, if they're side by side to each other, that means you multiply, and if they're above each other, that means you divide. So for example, let's say I want to find voltage. I'll circle voltage for now. I pay attention to the bottom two, right? So I and R, since I and R are right next to each other, you just multiply them. Bam. And then voltage equals I times R. Now let's say I want current. Look at the other two. Since V is above R, that means V over R, so you divide V by R, and V divided by R equals current. Same thing for the other way, same thing for R, V divided by I equals R. And that's a really cool formula that you can use to basically solve for any value in this, for any value that you want in the circuit. It gets a bit more complicated when finding total resistance and stuff, but I'll talk about series and parallel circuits, the different types of circuits, in a later video. I'm going to use this formula and put it to the test to actually show you what you can do with it. Okay, so as you can see on the right, I have my circuit, and there might be a couple of unfamiliar symbols that you're not used to. Here, let me just look at the first one. This is a resistor. It literally does what its name states. It resists the flow of electrons, right? It decreases the current. It increases the resistance of the total circuit. And as you can see on the left, there's a battery, which you can tell, and the circles are just the electrons, and the arrows are just the electron flow through the circuit. So let's try and solve for the current in this circuit. So we know that the total voltage is 12 volts because the battery is supplying 12 volts. And there's only one resistor in the circuit, so we know that the total resistance of the circuit is 6 ohms. So if we want to find the total current of this circuit, we're just going to use Ohm's law. And let's say in this case we're trying to find the current, right? So let me circle the current here. And since I equals, the V is above the R here, so I equals V over R. And let me substitute the values. I equals 12 volts over 6 ohms. Remember, always include your units. And in this case, I is going to equal to 2 amps. Now, if we did the exact same thing, let's say I removed this resistance value, right? And I gave you 2 amps. Use the exact same Ohm's law to figure out what this resistance is. And that's pretty much what Ohm's law is. Once you know the total resistance of a circuit and the total voltage, you can find pretty much the voltage and current anywhere once you take a couple of other factors into account. And I'll be talking about those factors in the next video in series and parallel circuits. So yeah, thank you so much for watching. If you have any questions, please tell me in the comments. And if you like this video, make sure to like and subscribe. And yeah, thank you for watching CoolCube. I'll see you in the next video.